So my name is Jarel Bartig, and my background is in landscape ecology and silviculture. And I work under a shared USDA position between the Forest Service and Natural Resources Conservation Service. And my primary role is to coordinate an interagency forestry team with focus on Southern Ohio and oak ecosystem restoration. And in my private life, my husband and I are also woodland owners in Pike County. So everyone participating in this webinar most likely feels a connection to woodlands. Many of us know that we feel better when we spend time in our woods, but it's hard to describe what that is to others or to quantify it in an empirical way. So today I'm going to share some language that'll help us describe this connection to our woods, along with some measurable evidence. My starting point for researching this presentation was to read a book called The Nature Fix by Florence Williams. I want to credit her up front because her work has greatly influenced what I'm beginning to understand about this pretty complex subject. So today I'm going to cover 3 kinds of solutions and the science behind them. I'm also going to share some simple techniques that you can try for yourself and some places to go if you don't own your own woodlands. And lastly, I did compile a starting list of resources if you want to explore this topic further. So the connection between time and nature and increased physical and mental well-being is gaining traction. Scientific research and documentation is growing worldwide. We can say that nature is good for civilization. Our nervous systems are built to resonate with set points derived from the natural world. Great thinkers like Darwin, Tesla, and Einstein all walked in gardens and groves of trees to help them think. Physical and mental well-being may sound vague, but the impact is very real. Enhancing it can not only add quality, but years to your life. So what's the disconnect? In 2008, the World Health Organization reported that more humans now live in urban settings than they do rural. For the very first time in the history of mankind, we find ourselves divorced from our natural surroundings. Humans have always experienced stress since the beginning of time. That's nothing new. But both the source of the stress and the way we respond to stress has recently changed. Higher order cognitive functions, including selective attention, problem solving, inhibition, and multitasking, are all heavily utilized in modern society, and they draw heavily on the prefrontal cortex part of our brain. You can think of this as our executive office taskmaster. We just don't allow for ourselves to recover, and our mental resiliency is fraying as a result. So even though urbanization has many benefits, it's also associated with increased levels of mental illness, including anxiety and depression. There are many reasons for this that are not well understood, but we're going to focus on one aspect today, and that is the directly corresponding decrease in nature experience. The global pandemic, civil unrest, and the uncertainty that comes with these things have all put us in constant fight or flight mode, further draining our reserves in a time when we need them the most. So today I'll explain 3 solutions that come from nature and the science behind them. For each one, I will cover the what, the where, and the how behind the ways they help our physical health and mental well-being. And I'm going to pause after each set for questions. So we're going to start with negative ions. So molecules floating in the air and charged with electricity are negative ions, or sometimes called anions. Negative ionization occurs whenever there are bodies of moving water. It's created by what's called the Leonard Effect. And this is when water crashes into a solid object and disperses up into the air. There's a separation of electrons from water molecules. The water molecules themselves are neutral and they produce just as many positive as negative ions. But when the negative ions break out, they remain suspended up in the air until they lose their charge, where the positive ions, they rapidly fall back down to the ground or to the body of water after impact. Lush vegetation with a well-developed tree canopy is another source of negative ions, just as long as there's enough water to create high humidity in the air. Also having good amounts of natural light, that's also favorable because negative ions are generated during photosynthesis. So where? Well, we might not have seashores, hot springs, or large bodies of water in Southern Ohio, but we do have plenty of places to come into contact with negative ions. The woodlands of Southeast Ohio are in the foothills of the Appalachians, and we're in a semi-temperate forest biome. Sometimes we're almost like a temperate rainforest. Our woodlands have rivers, streams, and even waterfalls, all running through them down to the Ohio River. And even our own showers are a source of negative ions, and they're why a shower can make us feel refreshed. So how does this work? So environments with negative ions are shown to be effective in reducing states of stress. Studies have shown improved cognitive function, both in adults and children, especially memory. Studies and experiments also confirm a direct correlation between these environments and improvement in depressive states of mind. Recovery is also quicker after physical exertion. And last but not least, negative ions also promote antimicrobial activity. So now I'm going to pause to see if there's any questions before I go on to the next solution.
So far, there's nothing in the chat box, Jarel, or in the question answer.
Okay, I'm just going to keep on going.
Oh, one just popped in. Hang on. It's from Jen. It says, do we breathe these in? That's her question.
No, I don't really know what the mechanism is. I didn't do that part of animal physiology, I guess. Should I keep going?
That's the only one I see. Oh, wait, is there an ion meter from Susie? Is there a way to measure it, I guess, is the question.
I think there is, because in the literature, they actually give numbers per cubic square meter. So I think there must be, but I'm not up to speed on what that instrument is.
Okay, and that's all I see right now, Jarel.
Okay, I wasn't too helpful on those questions. I'm going to move on to our next solution. So the next solution I'm going to talk about comes directly from the trees themselves. Shinrin Yoku means taking in the forest atmosphere or forest bathing. And you guys might have heard about this because this has been gaining in popularity. It's become quite trendy, but not everybody really understands what it is. So the term was actually coined by Japan's forestry agency in 1982. And it was to promote well-being in an overworked population that had one of the highest rates of suicide in the world. So most of the scientific research that we have today has come out of Japan in this body of work. And they actually have a school for more forest medicine you can earn a degree in. And this is not just simply a walk in the woods, but it's a contemplative practice of being immersed in the sights, sounds, and smells of a forest. And Korea is the second world leader in this field of research. So forest ecosystems, we've all heard that leaves soak up air pollution and carbon, and organic soil can bind pollutants and clean surface water, but there's just so much more to the ecosystem service story that these forests do for us. So I'm going to talk about what's in this tree air. So tree aerosols, or phytoncides, They help trees and plants protect themselves from insects and germs. They contain terpenes, which are aromatic compounds that give plants their scents. So when we say we smell spring in the air, we are really smelling tree aerosols. The nose is a direct pathway up to our brain, and molecules of a certain size can enter through the nose, bypass the blood-brain barrier, and go straight into our gray matter and our bloodstreams. And that's why some pharmaceuticals are actually administered up the nose. Well, tree aerosols are natural pharmaceuticals, and we're just beginning to document, appreciate, and study them. For example, one study that I read in the Central Sierras of California documented more than 1,700 of these compounds, and yet we know very little about them. So also in the tree air is another smell that we're familiar with. Geosmin is a molecule that actually causes something called petrochor. And that's when this molecule combines in the air with other elements, and it causes that mud and earth smell of gardening, or the smell that you smell after a rainfall. And this is coming from soil organisms, particularly the Streptomyces bacteria that are key to so many of our antibiotics. Geosmin as a molecule was only discovered in 2007. And according to the Royal Society of Chemistry, humans can detect very small amounts of it, the equivalent of 7 drops in a swimming pool. And camels can even smell geosmin in an oasis miles away. Geosmin's also the earthy taste in beetroots. It's the muddiness we might taste in some freshwater fish, and sometimes can even be tasted in wine. So where do we go for tree air? Well, intact forest ecosystems are the best source for taking in tree air, but benefits can still be had in parks, backyards, where there's trees. Ecosystem services are figuring now more and more in policy making and planning, and we're getting better at defining and quantifying them. It just seems really important to expand these assessments to include health and mental health benefits. And we're going to cover some mental health benefits shortly. So how does tree air work? We all know we feel better after a walk in the woods, but how can we measure improvement, direct improvement in our health when we do this activity? So some examples coming out of this body of research include lower blood pressure, lower blood sugar, measuring cortisol. This is known as our primary stress hormone when we're in our fight or flight mode. It's also shown to be lowered when we breathe in tree air. Cortisol controls blood sugar, it reduces inflammation, it regulates our metabolism, it helps control blood pressure, and it assists with our memory. So another big research finding is that our natural killer immune cells that we have, they actually increase when we breathe in tree air. These cells protect us from disease agents, and they can really be reliably measured. A type of white blood cell, they actually send self-destruct messages to tumors and virus-infected cells in our body. And we've known for a long time now that factors like stress and aging and pesticides can actually reduce our killer immune cell count, or at least temporarily, but breathing tree air can raise them. So how long do we need to breathe in this tree air? So studies have shown that not only an increase in cells after spending time in the woods happens, but this boost can actually last for days and even months. Further research testing the idea that it's the phytoncides in the plants that are responsible are being borne out, and a lot more research is to come. Now I'm going to pause right here before I go on to my final solution.
I don't see any open questions right now, but if folks want to type a question in, we'll take a minute to answer.
Okay, we're going to switch gears and talk about some of the mental health benefits. So when we spend time in nature, there are three major brain networks engaged when we walk across a natural landscape. We have that executive function network that I already mentioned, our office up there in our brain. We have a spatial network that helps us orient ourselves to our surroundings. And then we have something called the default network, and it's more active when we're passively resting or free ranging across the landscape, daydreaming, goal setting. This network is responsible for empathy, creativity, and insight. This process is most active when we're not focused on a goal-oriented task, not multitasking. It actually allows the executive office of the brain to rest and restore itself. I will mention that the default network also has a darker side, and it can lead to something called rumination. This is a prolonged and often unhealthy focus on the causes and the consequences of emotion, most often negative, self-relational emotions. And this pattern of thought has been shown to predict the onset of depressive episodes, as well as other mental health disorders. So distractions to break the cycle of rumination are really key, and they can help. And spending time walking in the woods or being out in nature serves this purpose. So to get that mental health break, we can give our executive offices a rest and restore ourselves anytime we spend time in a natural setting. Walking in our woods, taking in the view of a beautiful landscape, putting our hands in the earth as we garden, they all help us switch over to this default network. So parks, water, your backyard, even art can not only benefit us, but we actually require these things to be well as humans. So let's talk about the how. How does this work? We're just now starting to account for these psychological ecosystem services. Scientists are figuring out key characteristics of the environment, duration, frequency, and different types of natural experiences that generate different mental health benefits. Being in our woods helps relax us out of that fight or flight state that comes from the constant stress and worry of modern life. And we've already talked about studies that have shown an increase in focus and memory, and we know from our own experience that we just feel better when we're out in the woods. We talked about the dark side of our default network, rumination. More time in the woods can head this off as well. There's a couple more things to mention. What about increased awe? And what do I mean by awe? So if you look up at the stars at night or out at the Grand Canyon, we experience something larger than ourselves. New research coming out of UC Berkeley and Irvine suggests that experiencing awe actually promotes us to act more benevolently toward each other, to be kinder. Awe can help make the world a better place. And what about creativity? We could all use probably a little more of that. So there was another study that showed results where 4 days of immersion in nature increases performance on creativity and problem solving by a full 50%. So again, how long do we need to do these things? So time is very subjective, of course. And I mentioned earlier that the effects of tree air breathing can be lasting. And research is really still unraveling just how long. But I was surprised to learn that there does seem to be a clear number when it comes to spending time in nature for mental health. There was a study of 20,000 people by a team led by the European Center for Environment and Human Health at the University of Exeter. And they found that people who spent 2 hours a week in green spaces, either 2 hours all at once or spaced out over several visits during the week, were more likely to report good health and mental well-being than those that don't. And the same study also showed that there was no benefits for people who didn't meet that threshold. So 2 hours a week is a pretty realistic target for most people, especially if you can spread it out over an entire week and still get at least some mental health benefit. So I'm going to pause before I go on to some techniques.
So there were a couple questions in there that have been asked, and Lisa's already answered them, but I think it's probably a good idea to review them so everybody sees the answers, and then you can add to it if you'd like. But the first question is, who pays for this type of research? And Lisa answered that there's been a lot of research conducted by the medical community, but I don't know if you have anything else to add to that.
I'd say the medical community, and there's both. So there's a school of forest medicine in Japan. So that country's government has invested heavily on a lot of the physical statistics of well-being that I shared with you. But then there's different academic departments that are looking into the mental well-being. And you can kind of look at the journal articles and get an idea of who may be funding some of this research. But sometimes it's government, sometimes it's academia. That's really all I can tell you. I'm definitely not an expert on this, but I am learning.
So, and then there's another question from this guy named Todd Hutchinson. I don't know who he is, but
Todd.
He's asking about going back to the benefits of tree air. Is there any evidence for benefits of prairie or grassland air? And Lisa answered that there's not a lot of research, but it's likely that there are benefits.
So all plants make those phytoncides, and the literature is saying that that's what's really helping us. And so just by using logic, if all plants make those, I would think any intact ecosystem might be a benefit to us that way. But then there's the whole piece of mental health. If you're in a natural setting, whether it's a prairie and grassland or a woodland, you're getting benefit.
Thanks, Jarel. That's all the questions I see in the question and answer session so far.
Okay. I'm going to move on to some techniques that you can try to boost your health and your mental well-being. So another time frame referenced in the literature that I read about was a walk in the woods for an hour and a half to receive the maximum benefit of all the things that we've talked about today, both physical and mental. So there's another solid number the literature gave us. So finding activities that you can do while out in the woods is another option, especially if you're bringing children with you or you're trying to entice family members or friends to give this practice a try and they just don't know what you're talking about. This might help you get more people out there with you. So some ideas are that you could spontaneously create a beautiful mandala like you see in the slide out of the natural materials that you find while you're on your walk. You could try your hand at nature journaling while you sit at the base of a favorite tree, or just sit and breathe in the sights, sounds, and smells of the forest. So really, as the world gears up and businesses and schools open back up, we're all going to be contending with the fast pace of modern life. And spending time in our woods can be a really important part of maintaining our health and our mental well-being. So what about boosting creativity? And I know you see meditation on the slide, and before you say no way, hold up for a second. Meditation is really gaining in popularity, and it can take multitudes of forms, some of which are active, not just sitting and trying to empty your mind. So one of the more active forms is where you can work with the sounds, smells, colors, and the other perceptions that come from your immediate environment. Woodlands are a great place to do this. Pay attention to your feelings, your thoughts, or the sensations in your body while you do this. It's a great way to experience your woods and spend time restoring yourself. And if you're not sure how to get started, maybe just sit quietly at the base of your favorite tree. Take a deep breath in. Hold that breath, and then let that deep breath out. I'm going to mention just a few more ideas for family-friendly activities for enjoying the outdoors. There's a place you can go called Discover the Forest. And this has been a campaign between the Ad Council and the Forest Service meant to instill a lifelong love for nature in children. Another idea is you could read the iconic Dr. Seuss book called The Lorax to one of your children. This is a story about a forest creature who shares the enduring power of hope. something we could all use a little of these days for sure. Another idea is you could plant a garden. It's another way to connect with the earth, spend time outside, and you'll actually benefit from creating a more robust microbiome in your body through exposure to bacteria from the soil as you do this activity. And if you have to be stuck inside, you can still do things to design your inside environment to be more supportive as well. You can add negative ions to counteract your electronics by adding a salt lamp, a water fountain, or try burning a beeswax candle. These are all things that create those negative ions. So if you don't own your own woodlands, there are a lot of places you can still go. So almost all the images that you view today in today's talk come from places in Southeast Ohio, mostly on public lands. And one thing to remember is we're part of the Appalachian Mountains. We are home to the oldest and most biodiverse forest in North America. And in Ohio, we're lucky enough to have the Wayne National Forest. We have 24 state forests, 17 of which are located in Southeast Ohio. And we've got numerous state natural areas, each one with its own unique pocket of biological diversity to experience. So as I mentioned, I have a couple slides in here that are a starting list of books and websites that we can make available for those of you who want to go further with this topic. Just to give you an idea. I want to thank everybody for your time and your attention and your thoughtful questions, and wish everybody to be well.
Thanks so much, Jarel. Just a reminder, we will put those links on those folks that attended the webinar, and we'll put them on that website that I showed you earlier. So you'll have access to all those links later. So don't worry about getting them all down. And then we'll also have this recording so you can pause it there if you want to look at it that way. So those will be available. A couple questions that came through, and the one that's still left has been unanswered is you keep referring to an intact ecosystem. What does that mean to you?
So an intact ecosystem is where you still have the original assemblage of trees, plants, and animals and their relationships to each other all together in space and time. And it's different than a garden where we plant maybe rows of a crop. Instead, an ecosystem has all of these biological connections, so many that we as humans can't even map and understand them all. That's the way I would describe an intact ecosystem.
Okay, thanks. And then there's another question. Would it be harmful to be in a hemlock forest area? And Lisa asked for a little more explanation on that one, but I'm wondering if it's a tie to poison hemlock and there's some confusion there. That's my guess. Hopefully not, because I love spending time in a hemlock forest. That's the most relaxing place in the world, I think.
So I'd say not. Definitely, if you read in the literature, the forest medicine literature, a lot of the research they've done on compounds that they've isolated that directly benefit us actually are conifers. So I'd say not. And there is a big confusion about hemlock, plant, tree, poison. Who is it? Socrates. But I think walking in a hemlock forest is not a bad thing to do.
Yeah, there are, as far as I know, it's unfortunate that hemlock is used for the plant that can be poisonous, but our hemlock forest it's a totally different situation. So
correct. Beautiful place to go.
let me make sure we've got a couple open ones now. More popping in. Yeah, someone just kind of reiterated that the hemlock that killed Socrates isn't the same hemlock. So that is definitely
it's a plant. True. Correct. Thank you.
There's some kind of bad fungus in one of our pine forests, ? So I'm not sure what that's referring to. But there are lots of fungi out there. And I don't know if you want to add to that or not, Jarel.
I'm not a forest health specialist, so I'm not going to try to say anything on that.
So there are lots of fungi that are not healthy for trees, and some of them are dangerous for us if we consume them. by eating them. But as far as I'm aware, I don't know that being near them would be an issue at all. So if you want to clarify that question, feel free to, Nikki. And then there's another one. If you walk in an area where the trees are poisonous, would breathing the air be harmful?
So I don't know about, so a poisonous tree that I can think of that we talk about in Southeast Ohio is an invasive tree called tree of heaven, which when you break it and come onto contact with it and breathe in, that could be bad for you. But just walking in a forest and breathing air, I think the worst thing that can happen to you is some allergies.
Yeah, and I agree. The ailanthus or tree of heaven can be quite harmful if you're sawing it for lumber or cutting it up, because there's some evidence that it can cause some cardio type issues, and they tend to be temporary. But as far as just walking through a woods with them, I don't know of anything either. And let's see, are there any more open? Can you see those questions at all, Jarel? If you click on the Q&A to make sure we've got them covered.
Can I get out of my slideshow because it won't show me anything in the slides?
Sure. So I'll start from the bottom up. There is a university in America that actively studies forest medicine. Or is there? I'm sorry. Is there a university in America that actively studies forest medicine?
I don't know, but I am not the end all to this topic. So I have seen National Park Service offering certification programs in leading tree air breathing hikes, but I don't know of a school of medicine like what Japan offers, but I'm not the final say for sure.
Okay. And then Nikki, who asked the question about the fungus, typed in sporotrichosis. I'm not familiar with that one. I don't know how to answer that.
So there, I mean, you can definitely read accounts of spores that you breathe in that'll make you sick for sure. And depending on how you come into contact with them. But just in general, walking through a woods, it's hard to pinpoint out a correlation like that.
Right.
And I have the chat open, but I can't, there's no words in my chat.
Okay. Yeah, it's actually in the Q&A, and I think we've got all of them answered at this point. So
great.
Thanks so much, Jarel. That was always interesting, and you're making me want to get out in the woods again today, this afternoon, but I got videos to edit, so I don't know if that'll happen or not. So one more just popped in. Poison ivy sometimes takes over a tree as a parasite. If the wood is inhaled, would it cause respiratory irritation and problems?
I don't think so. Just the poison ivy problem is contact.
Yeah, and I have heard if you burn it in a campfire or so, you could breathe it in that way, and it could be an issue. So I would definitely remove it, the bulk of it, from the wood before you burned it, but only in that situation is the only place I've heard it being an issue.
And also, if you're weed eating and you're chopping it and it's splashing up on you,
the possibility.
That's not so great. But again, walking through it and breathing is not going to hurt you.
Okay, well, thanks again. And I think we'll go ahead and turn it over to Lisa. So we'll let Lisa load up her PowerPoint, and I'll do a brief introduction. Lisa is the Ecology and Botany Manager at the Wayne National Forest, and she's also the Climate Change Coordinator, and she's new to the Wayne. So welcome to Ohio, Lisa, and it looks like we're getting ready to.
Right, am I coming through loud and clear?
You're sounding loud and clear, and I see your PowerPoint, so I think we're good.
Excellent, excellent. Well, good morning, everyone. I'm super excited to be here talking today about ecological zip codes. I need no further introduction, as Dave did a great job. So yeah, let's hop into this. I'm going to give you a quick introduction here to the ecological subsections of Southeast Ohio. So to get started, I thought we'd talk about, what the heck is ecological classification, right? That sounds like some voodoo stuff going on. Then I'd like to cover why would we go about classifying and mapping our ecosystems? But I want to make sure that the meat and potatoes of this presentation really is going to be about the eco-zip codes of Southeast Ohio. So without further ado, what is ecological classification? Well, honestly, it's as simple as, we classify individual species. Why not individual ecosystems? And this is something really cool that can be done by grouping distinct geographic units across spatial scales. What I get really excited about with eco-classification is it's this beautiful marriage of the biotic and abiotic worlds. So biotic being our living world, we usually associate that with plants, and then our abiotic world. This is the non-living side, but it's just as important, and it covers things like topography, geology, hydrology, soils, all the good ologies in there. Cool, Lisa, we know about eco-classification. How does it work? Well, why would we do this in the first place? Allowing us to group lands that have similar capabilities and potentials just makes for smoother management and conservation activities on the ground. Mapping them, this is where my brain really needs the help, is I'm a very visual person. And so being able to map the ecosystems, it's a lot easier to be able to pick out those patterns and processes across a landscape. I mean, we can go and we can stand out there and look, but it's not quite the same as being able to put a bigger landscape on our computer screen and pull up the information that way. And in terms of ecological classification, the Forest Service uses what's a big mouthful here, the National Hierarchical Framework Ecological Units. In short, let's go with EcoMap. It's a little bit easier to say. So I'm going to give you a quick little walkthrough of what EcoMap is. So I mentioned it's a hierarchical framework. We've got these 8 different tiers here, and each of these represents a distinct ecological unit. So starting up at the very top, these first 3 ecological units form what's called the ecoregion. These are our super broad breaks that we make at like the biome level and very broad climatic breaks. These are large units, about millions of square miles. Stepping down to our subregion section, now we're getting a little bit more refined. This is where we're looking at regional climatic patterns, regional geology, soil phases, and we're stepping it down now, getting a little bit smaller, talking about tens to thousands of square miles. And all the way down here at the bottom, our landscape and land unit tiers. This is the work that's really done at the lower level. So here on the Wayne, this is our bread and butter. This is what we're going to be looking at. And, we evaluate things like elevation, landform, slope, the local rock types, and then vegetation also does come into play here. And these are much smaller units. These are tens to hundreds of acres. And depending on where you're at in the country, these can be less than tens of acres. All right, so where do our eco-zip codes fall right in here? Well, we're on that lower section there of the subregion there, where we're going to be talking about the subsections. So subsections are equivalent to our eco-zip codes. All right, well, before I do a live little walkthrough of what this classification delineation work looks like, figured it might not be too bad of an idea to talk about, well, what value do we gain looking just at that subsection level? Well, right off the bat, being able to look at that scale, we can have a better understanding of how human activities are affecting the environment. Looking at subsections can also help us with ecological design and description when we're trying to do analyses for things like landscapes, watersheds, even riparian zone management. This is kind of the area I tend to hone in on, but it's figuring out and describing those baseline characteristics for the environment and the vegetation. And then we can utilize that information to look at departure or broad scale changes that we see across the landscape. I kind of always have talked about it, if we don't understand how our landscapes functioned and looked like historically, how can we, expect to fully understand what we're seeing now on the ground? Okay, so I kind of already just touched on this one, being able to explain landscape concepts and their ecological characteristics. But another really, really big one here is the ability to evaluate our biological diversity and then the connectivity opportunities that are available within that landscape. All right, so I'm just going to take this next screen right here to really quickly show you graphically, again, Lisa and the map mind, show you graphically what this classification looks like. So starting here, I've got the Eastern US pulled up, pulling up that very, very top ecological unit of domain. The light green, that is shading in a good chunk of the eastern, pretty much the eastern half of the US, that is delineating our humid temperate domain. I want us all to be keeping our eyes out on that Southeast Ohio area so we can see how the different hierarchies are going to get pulled out here. All right, so stepping down to the hot Continental Division, that's shown there in the darker green, again, fully encompassing Ohio. And breaking out our province, now we're starting to see some more refined splits. The blue there is showing us the eastern broadleaf forest oceanic component of the province. Dialing it down even a little bit more, we get to the southern unglaciated Allegheny Plateau, that nice orange section. So you can see now we've really, really honed in on getting to our eco-zipcodes, which I know what we all want to talk about right now. So I'm going to zoom us in a little bit closer here to Southeast Ohio and try to identify most of the counties that get touched by this southern unglaciated Allegheny Plateau. And let's take a look now at the eco-zip codes that we find. Here in the purple, we start out on the east. This is our Ohio Valley lowland. Moving further east is our East Hocking Plateau. Up to the north is the unglaciated Mesquingum Plains that's been delineated. And just below that is the Western Hocking Plateau, followed by the Lowercyoto River Plateau. I know right now that's probably just a bunch of words, so it seems like gobbledygook. So I'm gonna now kind of dive into the abiotic and biotic patterns that have been identified that have allowed the much smarter researchers than me have allowed them to be able to create these divisions. So starting with abiotics, this is just going to be an overview of a sample of the abiotics. This is not all encompassing, don't have that much screen room. So starting with the Ohio Valley lowland, the parent material that really defines this area is 300 million year old sedimentary rocks. Again, we are unglaciated, so we are going to see some very old parent materials in here. We have a high clay component in our soils. These are our fine, dense soils, and it definitely shows as a significant or as a distinct pattern here in this particular part of the landscape. Average pH is hanging out in that lower 5-ish range. Our elevation is 702,000 feet, so we're pretty moderate up there. But what's interesting to note, though, is our average slopes are hanging in at right around 12%. You can see, we've got a plus or minus there of 8%, suggesting that this is a rather steep and rugged area. And it makes sense. You've got the low bottomlands of the Ohio River, and then it is going to dive up into the uplands. An average annual precipitation down here is about 43 inches a year. Okay, moving on to our East Hocking Plateau, we've got similar parent material, but this stuff's a little bit older, just a little bit, right? 302 to 307 million year old sedimentary rocks. Our clay sand ratio is similar, but not quite as dense. Average pH, this one jumps up quite a bit higher. Of our 5 subsections, this will be the highest average pH at 5.8. Elevation, this one it's similar, but our slopes are not as drastic. And so what we tend to see here is a bit more of a rolling type topography. And average annual precipitation is about 40.6 inches a year. Moving on to our unglaciated Mesquingum Plains, Now we're starting to see some differences. In addition to the sedimentary rocks that we've been seeing, we are also starting to pick up some deltaic and marine conglomerate and glacial fluvial deposits. And this totally makes sense because this area is starting to get into that transition zone from the glaciated landscapes into the unglaciated. And so as those glaciers were receding, we do see those glacial fluvial deposits influencing this landscape up here. Our clay sand ratio then is a really good further example of some of those higher sand contents starting to come in. Average pH is going to hover around that mid-5 range. Elevation is higher, but interesting to note that the slopes are a bit more mellow. And precipitation here is actually the lowest of the 5, coming in at 40 inches a year. Our Western Hocking Plateau is actually going to look pretty similar to our East Hocking Plateau. Parent material again is repeated, but we are starting to pick up some marine limestone in the conglomerate. And this one is also seeing a higher sand content similar to the unglaciated Mesquingum plains, and that high sand. Wow, it's a higher sand content that is coming in from the eroded sedimentary rock parent material. Average pH is kind of low here, sitting at 5.1. Elevation is similar again to our neighbor to the east, and again similar slopes. And so, you know, we're seeing that gentle but rolling topography still, and our average annual precipitation of 41.9 inches. And last but not least, we have our Lowercyoto River Plateau. Parent material is, oh, sorry, I just got a little thing showing up on my screen. Sorry about that. Lowercyoto River Plateau's parent material. Now we're starting to see some marine origin sedimentary rocks, as well as some glacial outwash sands, which again is a good explanation for how we're seeing these higher sand contents coming in. Average pH, still on the lower side at that 5.2, so similar to the Western Hocking Plateau. Elevation, this one's going to be similar to the Ohio Valley Lowland, and once again, it totally makes sense. You know, we've got the Lowercyoto River in there, as well as the Ohio River, and again, we've got those low bottomlands that jump up to the uplands quite rapidly. So again, steep and rugged topography, and average annual precipitation of 43.1 inches. So this is a whole bunch of information, and you're probably looking at it thinking, wow, Lisa, that's not a whole lot of difference. And you're right. I mean, there's not a lot of difference, but there are certain areas that do pop out as being, you know, significantly different from the others. And that abiotic information definitely does then feed into the biotic side. So let's go ahead and take a look at that. We're going to redo this, but we're going to start by looking first at tree biodiversity. So pulling up the Ohio Valley Lowland, I'm going to have two different columns. The first column I'm going to show is going to be the top 5 or 6 species that were the most prominent in the witness tree data. So this would be pre-settlement information. And this information, it's looking at abundance only. So the information is going to be presented in percentages. The second one that I will show, I'll wait. We'll go ahead and take a look at the pre-settlement data first. So with the pre-settlement in Ohio Valley Lowland, we saw that 53% of those witness trees were white oaks, followed by black oaks. And black oaks is written in the little asterisk there because the early land surveyors didn't break out scarlets from black oaks, from northern white oaks, and they kind of all got lumped together. And same thing with the hickories. And so, yeah, for what it is, the black oaks have been lumped together, coming in at 14%, followed by hickories, chestnut oak, and beech. I've got pine down there, not because it is the next most numerous species. I've got it up there because pine showed the strongest affinity to this particular subsection, which I thought was kind of interesting. Looking at the current day importance values. So this information is coming to us from the Forest Service's forest inventory and analysis data. And these importance values, they're not a one-to-one with the witness tree data. Like the witness tree data, they do take in abundance, but a relative abundance, but they also take in basal area as well. And so these are presented as numbers and not percentages. And so while we can't do a one-to-one comparison, we can still identify patterns on the landscape. And what we see on the landscape in the Ohio Valley lowland is we've got sugar maples and white oaks with kind of similar importance values, then dropping down to the red maples, hickories, and tulip poplars. Going over to the East Hocking Plateau, our pre-settlement witness trees look somewhat similar. We do see sugar maples starting to pop up in that list of top 5, but again, our white oaks are certainly our dominance and pretty obviously. We look at our current day importance values though, and it's quite a bit different. We see shifts on over to sugar maple, black cherry, American elm, black locust, and red maple. On to the unglaciated Mesquingum plains, and I have to apologize, I don't have witness tree data. So I've got oaks listed there, and I'm comfortable stating that. And on the next slide, we'll kind of talk about why I feel okay saying that oaks were very likely the dominant pre-settlement witness tree data is there. But current day, again, it's another pretty different story here. We're looking at red maple, black cherry, tulip poplar, American elm, and big-tooth aspen. Over to our Western Hocking Plateau, the pre-settlement abundance was, again, similar to its eastern neighbor there. But what was kind of cool that I thought in this one was chestnut. I mean, it's a low abundance. It came in at only about 2.5% of the witness trees, but it was interesting to note that, you know, this is where it starts picking up. I'm not sure if there's an understanding that chestnuts, it was all over the pre-settlement landscape. Our witness tree data from Ohio is showing us something different. You know, chestnuts were here, but they were not necessarily a dominant component of the landscapes, and it certainly looks like they had certain areas that they preferred over others. And so the Western Hocking Plateau is certainly one of those. Current day importance values, though, we're starting to again see a little bit of a different trend with red maples and tulip poplars right up there at the top, then followed by white oaks, sugar maples, and chestnut oaks. And lastly, looking at our Lowercyoto River Plateau, a story. Are we getting tired of hearing white oak always coming up at the top of the list yet? But that is certainly an important pattern. But it's interesting to note that, you know, their abundance is a bit lower than it is in the other areas, but it's still followed by hickory, black oak, sugar maple. This is another one where chestnuts formed a component of the witness tree data. It was about 2.9%, if I believe correctly. Current day, though, it's telling us a little bit of a different story, though. We're starting to see more importance in the sugar and red maples, followed by chestnut oaks, tulip poplar, and white oak. And I think, you know, there's a kind of an important message in here. Again, I know there's a lot going on in this slide, and I think it's helpful to see everything side by side, but there's part of the story that's not being told in this slide, and it's that tree biodiversity was very high, and it still is very high. And for any land manager, you know, that's a great goal for us to keep in mind and want to be shooting for moving into the future. But as land managers, you know, looking at the current day information and what it's suggesting, you know, it kind of brings into question future forest trajectory, and are we at risk for losing that biodiversity? All right, so we took a look at tree species biodiversity. Now I thought it'd be kind of cool to take a look at forest type diversity broken down by the subsections. So in our Ohio Valley lowland, it's pretty obvious. Mixed oak forest, they took the cake there. More than 70% of that landscape was dominated by mixed oak forests. East Hocking Plateau, similar, but not quite the same story. Mixed oak forests were just slightly more than half, and almost equal components of beech forests and mixed mesophytic forests. Okay, so this is why I was comfortable saying that oaks were very likely a strong component of the witness trees for the unglaciated Mesquingum plains. I mean, check that out, almost 77% of the landscape was classified into this mixed oak forest pre-settlement type. Our Western Hocking Plateau, similar story to the ones above. 74% of the lands were mixed oak, and then smaller components of the others. Our Lowercyoto River Plateau looks a little bit different though from the others. Our mixed oak forests were the second most common. The mixed mesophytic forest is the one that was our dominant. But it's really important to note that, so this information all comes from Gordon's 1969 pre-settlement map. And his definition of the mixed mesophytic forest was in line with Braun's 1950s classification, where this whole area fell into that mixed mesophytic forest region. But even in Braun's writings, it had noted that this particular part of the mixed mesophytic region, so Southeast Ohio, bits of Kentucky, all the way up into bits of Pennsylvania and West Virginia, was comprised of larger shares of oaks than the rest of the mixed mesophytic forest. So it just is kind of going to show that tree diversity is high, and that's super excellent. But those oaks certainly served as the architecture for our landscapes here in Southeast Ohio under pre-settlement conditions. Okay, and I thought it would be interesting to take a look then at, well, what does our current day landscape look like? This might be a little bit dated. As you can see, this comes from the 2015 land cover data set, but it's probably not wildly off. So looking at the Ohio Valley lowland, it's still mostly forested, almost 70%. About 28% is really what's going to human managed landscapes, so the developed as well as the crop and pasture. East Hocking Plateau is telling us a similar story. Our unglaciated Mesquingum plains is a little bit different. So slightly less than half of the landscape is in forest, whereas our developed and crop and pasture landscapes are higher. And this totally makes sense because let's face it, it's a lot easier to build and farm on flatter lands. And so being that this one has the gentlest slopes, pretty obvious why our crop and pasture and developed lands are higher. All right, moving further west over into the Western Hocking Plateau, this is getting us back to what we've been seeing in the first two subsections. And the Lowercyoto River Plateau tends to follow that as well. Okay, so that was like a ridiculous amount of talking and numbers and words and things like up on the slide. So I'm going to take a cue from Jarel right now, and I am going to just have a step through each of these subsections and look at some really nice landscape photos and see if we can take all the stuff I've talked about and kind of be applying it here to these photos. So these are two great shots of the Ohio River looking up into those uplands. And yeah, you can see that nice flat bottomland where those slopes are going to be a much shallower, but it pretty abruptly shoots up, where we can start to see those 16, 17, 20% slopes. Moving on over to the Eastern Hocking Plateau, I know Dow Lake down here at Stroud's Run State Park, that's not a natural feature, that is, human developed, but it presents a really good opportunity to be able to see that rolling topography that is defining of the East Hocking Plateau. It's Jarel actually said it to me really nicely the other day when she said, the only thing homogeneous about the Southeast Ohio landscape is the heterogeneity of it. And it's very true. I mean, we are consistently up and down, so to speak. Jesse Owens State Park, though, it's a really interesting opportunity to again, you can see that rolling topography, but now we can start looking at land capabilities as well. So surface and subsurface mining, has definitely shaped the landscapes down here. And here at this state park, you can see in the foreground that area of grassiness. These are lands that have been disturbed and reclaimed now. And just the nature of the reclaimed soils makes it very, very challenging to get trees established. And so that capability for forest land, likely not there anymore, but the capability to support grasslands, very well supported there. So our unglaciated Mesquingum Plains gives us a really good overview of that. And I love this overview of the Tri-Valley Wildlife Area because it really shows that interesting matrix of forest land interspersed with these reclaimed grassland areas. You know, this is a very defining feature of that particular section. That photo there at the bottom of the wilds, that's a great panorama. Man, when I found that one the other day, I was like, oh, now that is a landscape photo of the unglaciated Mesquingum plains if ever I've seen one. But it's a really good way to be able to see the land still rolls, but those slopes are definitely gentle, you know, compared to looking at the Ohio Valley lowland or the Lowercyoto River. The Western Hocking Plateau. Who here has been to and, you know, thoroughly adores the Hocking Hills? That's a really cool area to be able to go and experience the geology up close. That, you know, that is so striking and defining of Southeast Ohio. But this shot that I've got here from the Wayne National Forest down in the Ironton unit, again, it provides another really good example of, yep, we're rolling. Yep, we've got some pretty decent slopes and it's consistent. And then last up, I've got these, you know, really, really gorgeous shots here of the Lowercyoto River Plateau. You can see that one at the bottom there, the Scioto River. Jarel also had in her presentation. Shawnee State Park, that one would be off of the Ohio River. And, you know, again, similar to the Ohio Valley lowland, you've got those broad, wide floodplains, you know, that provides little topographic relief, but then boom, we shoot up to those uplands pretty darn quickly. That photo of the Shawnee State Forest, though, I thought was pretty cool because, you know, folks may or may not have heard that, you know, that part of Ohio is oftentimes referred to as the Little Smokies. And that just seemed like a really great photo displaying that, you know, you've got that nice blue tinge, but, you know, the rolling, well, actually up here, it's a bit more steep and rugged topography here, but it's just a beautiful shot. So again, I can't reiterate enough how much you know, dense information I kind of plopped into this presentation here, but you know, I am by no means the architect of this at all. There are people much smarter than me that have done the research and continue to do the research on this. And so folks who are interested in, you know, maybe refreshing a little bit on what was in this presentation or even digging deeper, this is a free publication that is available online. Would be happy to put that link into the chat for folks. But it's a short document. It's only about 70 pages long, but man, there is a ton of information in there. So go out, grab a copy. I think I need to get a new one. Mine's falling apart. I use it so much, my pages are coming out. And so with that, I thought I would just, you know, challenge everyone to go ahead and take an opportunity, follow Jarel's advice, get your vitamin N, your vitamin nature for the day, and start exploring, you know, these beautiful lands that are Southeast Ohio, and see if you can't maybe start picking out which eco-zip code do you live in. And with that, I am all done.
Thanks so much, Lisa.
Yeah.
We got a few questions in the Q&A. You can probably see them too. So however you want to do that, you can either take the lead on them, or if you want me to help facilitate that.
Well, I'm trying to figure out here how to stop sharing. Oh, there's the button right there.
There you go.
Okay, I got it.
So there is a bit of discussion about the wilds, about it being reclaimed strip mine.
Yeah.
And it certainly is. That area is right in the middle of some of the heaviest mining. It's right where the big Muskie shovel, one of the largest ones in the country, but they reclaimed it, and it has a kind of a similar rolling approach of what it would have, but certainly not the same.
Right.
And let's see, starting at the top, there's a question about, so there are less oaks, are the current day importance values, what is actually there now?
Yes. And so I'm really hoping to not butcher it, because I know, you know, some of that publication I put up there are some co-authors on the call right now that I would love to call them out instead. But yeah, the story is kind of showing us in terms of trajectory, we are seeing less oaks. And so there is certainly a concern that oak component, that biodiversity of the oaks may be threatened here in the future.
Jarel, you want to jump in there?
Please,
on
Jarel.
oak, please.
I'm just going to add a little context to what she said. So we have a story of looking at our canopy right now, which we still see a lot of oaks in our canopy, but we also need to look at our understory because that's going to be our future forest. And that's where the biggest change can be observed right now. And it's kind of a nuance to try to get across. There is a lot more urgency than we realize. Just because we have big oaks over our head doesn't mean that if a tornado came and took all those oaks down, the future forest that replaces that may or may not be oak. And that's where the trend is really shifting. And you saw Lisa's statistics on this.
I have typed in the website on where you can get that free PDF online. So if I answer that question correctly, that should be showing in the Q&A under the answered. If I need to drop that in the chat, let me know too.
It probably wouldn't hurt to dump it in there too. And just a reminder, after the webinar, we'll post a lot of these resources. So we'll put all those links and it'll be on a one-stop shop for you. So you'll just be able to go to that post and click on those.
Okay, it's showing in the chat now too.
And there's one in there for you, Jarel, or it's just a follow-up, I believe, on some of our discussion about the forest health side of things, or the health aspects of the forest. So let's table that one and make sure we get all the ones related to Lisa first here. There is a question about will it be available later, and the answer is yes. It'll be on this site, and I'll just type that in. And I'll send out an email to everybody that registered for the program when we get that link available. We'll wait for the recording. We'll come up with a list of resources for Jarel's talk and a list of resources for Lisa's talk, and we'll post them all in a nice, neat package for you up there. So question from Monica about how we support and encourage oak growth in the understory. Well, that's setting us up there, Jarel.
That's a big topic. That's a really, really big one. And I think the take home message for me is it's a landscape scale concern. And, you know, if we really are to have success at supporting and encouraging it, we need to take a landscape scale approach. And so, you know, we may each have our own little plot of woodland, but banding together and managing, you know, for larger landscapes, I think is the first step. Jarel, if you want to pop in with some suggestions on some tactical things perhaps that folks can look at and maybe where there's support for that.
Yeah, and I'm also going to direct back over to Dave because some other talks in the Friday series may help people delve more into that. So as I mentioned, so oaks are a very long-lived species. These forests kind of set themselves up in the understory before we get to what happens in the overstory, which defines the stand. So interventions between now and when that overstory changes, that's part of the solution. And there's a lot of intermediate silvicultural treatments you can do to help guide the trajectory of that stand development. So it'll be the future forest for our grandchildren that we saw when the first settlers came, or it'll be something completely different. I'm going to stop talking about general concepts and see if Dave wants to talk about other Friday series talks that might help talk about these interventions that I'm mentioning.
Yeah, I don't think we have anything scheduled for the future. I'll have to go back and look. I know we've got some recordings of some of our talks on how we can manage our oak woodlands. But kind of the big thing is that's changed over time is the disturbance regime that's out there. And then a lot of these forests, you know, are not natural forest in that they've followed disturbance from our European settlers too. So, but the big thing it's missing or is not as common on the landscape is fire. So that's one of the things that favored oak. But essentially what we've got is a situation that under these oak dominated canopies, we've got too much shade. It's just not enough light for oak to get started. So there are some practices that you can use to get a little more light to the forest floor when it's time to regenerate that forest. And ideally, what you'll want to do is talk to a forester to help you assess your site, because every site's a little different. It's a lot different up on those dry ridges where we've got chestnut oak and scarlet oak versus down a little bit lower on the slope. So I know that's kind of broad, but there's, you know, every little bit. Lisa mentioned how diverse this landscape is. So there's not a prescription that works everywhere. So we kind of got to look at each piece of the puzzle and then make individual recommendations. But it's usually about removing some mid-story trees and shrubs that are blocking that light to the understory. And that's kind of the key to success.
I'll just add on to that really quickly, if I could, that, you know, this transition, it hasn't exactly been a slow one. It was kind of like the perfect storm that happened down here in Southeast Ohio, you know, when massive settlements started taking place. I mean, we had extensive like landscape scale clear cuts. We've had mining, you know, farming activities. So rather than just some natural disturbances that happened, you know, in areas across space and time, it seemed to be in one space and one time there was this massive effect that had happened to the landscape. And it makes sense. I mean, those light seeds that are easily blown around are ashes, maples. Those are the ones that have colonized. And yeah, as natural disturbance regimes have changed, it has allowed the perpetuation of these other species and not been mostly in favor of oaks.
Okay, another question is from Maurice about chinkapin oaks. Are they part of the same beneficial oaks we're talking about? Do you want to talk a little bit about chinkapin oak, Lisa?
You know, I don't have my poor falling apart little green book on me, but I'm pretty certain that, you know, chinkapin oaks were a group that were also, you know, identified in the witness trees as well. And that's why we don't make money off of the publication. So it's not like, you know, I'm pocketing any money, but I do encourage people to go ahead and obtain your free copy of it and to be able to dig real deep into, man, the massive amount of research that went into it and just the synthesis of the information that's available. But yes, chinkapin oaks, 100% part of our oak dominated ecosystem down here in Southeast Ohio.
And I can add just a couple pieces about chinkapin. They tend to have a little more affinity to calcareous soils, so they're not as evenly distributed. If you go more west over to some of the holdings at the Arc of Appalachia or the edge of Appalachia Preserve that the Nature Conservancy manages, and I believe there's some public land opportunities there, you're more likely to run into a chinkapin.
Yeah, chinkapin is definitely much more common in southwestern Ohio. So as you pop over into western pike and to the west, you see a lot more chinkapin. But there are little pockets that are hiding out there, and it's cool to stumble into them. Question about the lack of predators for deer and how that affects our oak regen. And I can take that one if you don't mind, because I actually did some research on that a few years back. But essentially, deer definitely have an impact on our forest ecosystems. We are very fortunate in Ohio and Southeast Ohio in that our deer densities are pretty manageable. They're at levels that aren't really driving the system. If you go to Pennsylvania and New York, especially 10, 15 years ago, they had such high deer densities that they drove the ecosystem greatly and changed it dramatically. They had 80 deer per square mile, and we're probably less than 20. But they do have an impact. They selectively browse, and I guess the other piece to it, a lot of our non-native invasives are not really favored by deer. So when you have deer densities that are high, it kind of gives those non-native invasives a boost as well. So, but in general, the study I did, deer aren't the driver so much in our oak regeneration issue in Southeast Ohio. It's more the lack of sunlight that affected. But when you're in dense shade, deer can do more damage than they can when there's a little more light on the scene, because the trees will grow a lot faster, the regen will grow faster. So the shadier it is, the easier it is for deer to keep up with it too. Okay, question about the rest of Ohio. And there was a question, I apologize, I think it kind of got slid up, but how do you, I know the question that came in was something about the zip codes in northwestern Ohio and how would we get that information? So I don't know if, because we've got folks on that aren't all from Southeast Ohio, where would they find that same information for other parts of the state?
I don't think the rest of the state has really had this level of ecological classification. I mean, as far as the eco map side of things, we don't have any national forests in the rest of the state. And so there hasn't been a directed focus to covering that right now. And I hope I'm not, misstating or misrepresenting anything, but that's the way that I understand it. But man, if there's a desire, let's make it known so that we can get this level of information available across the state.
I'm just going to build on what Lisa said. So she showed us that this was a hierarchy. So there are nationwide maps at certain levels of the big parts of the hierarchy, but the zip code information that she just presented in that level of detail, both on the unglaciated plateau and the zip codes, and the compilation of information that you'll find in that publication, that's unique to this part of Ohio. Other than that, there are individual papers of a watershed here and there that talk about ecological classification, but there's nothing as comprehensive as the publication that Lisa's sharing with us today for the rest of the state.
And it's just a matter of limited resources in Ohio, and the forest is down here. I mean, we've got so much, a high percentage of the forest here. That's where the investment is, in the fact there's national forest down here and a lot of our state lands. So in the chat from Susan, there's a question about it being very labor intensive to girdle maples and avoid disturbance from fire. It wasn't a common natural occurrence in these forests, was it? So it's a question and a statement there. So how common was fire? And I don't know, I checked the list a little earlier. I don't think Todd's still on, but he would be the guy to answer that. Let me just see if I can find him in the attendee list.
I was going to try to make him talk.
I can't find him. I was going to promote him before so he could talk. But Jarel, did you want to just talk a little bit about how common fire was on the landscape? And then I can address girdling as a potential.
Yeah, so there's a big debate talking about this disturbance factor, and I think we have to really think about how old our ecosystems are. And so these oaks have been a dominant piece of the landscape for thousands of years. And there is a whole span of time at which this system functioned with indigenous peoples before European settlers came. So that's when the system actually developed. It had a common disturbance regime, and the manipulation of the landscape by the indigenous. Now today, it's us manipulating the landscape. That's where that natural fire regime got established. But as Lisa pointed out, in the short span of time, the 200 or 300 years that European settlement has impacted the landscape, it's been a very big impact, and it wasn't the same natural disturbance regime. And so when people talk about fire as a silvicultural tool, and they try to understand how fire might have functioned naturally, we oftentimes discount that whole big, long pre-settlement time period. And you can learn more about it in that publication. And we only focus on kind of the atypical things that happened over the past 200 or 300 years. So that's a problem in our understanding. And then you can also have a conversation where just how does it work as a silvicultural treatment tool? And there is data behind that to show you the results if you choose to use this as a silvicultural treatment. I'm going to pause there and let Dave take over with his piece of the question.
Yeah, so fire is a tool if we want to manage oak, and we realize it's probably not realistic to be at oak levels at the time when they were doing the survey work for the witness trees, but we're seeing such trends that we're really worried about it, and we feel that oak is so important for a lot of reasons, ecologically, economically, environmentally. Climate change is something to consider as well too, and oaks will do quite well under most of the scenarios that are projected. So it's important, I think, and we've made it a priority to keep oak. It doesn't mean that in the coves in the low-lying areas, it's going to be very difficult and probably not cost effective to try to get oak on some of those landscapes, but to at least maintain a component of oak-dominated forests is important. And fire is a tool. It's a tool that's not readily available for private woodland owners yet. It's commonly used on our state forest, or much more commonly than it was. And it's also being used on the national forest and wildlife areas. But it's a tool that can help to encourage oak and favor oak. But there are other tools. There are things you can do either by cutting. There are some things I know Todd, I wish he was on, because we haven't talked a little bit about a study he's doing where he's looking at using herbicide injection to remove that mid-story to try to get those little oak seedlings established so that they can be competitive later. There may be even some potential, and not a lot of research on it, but I'm a firm believer the property I live on here in Jackson County had a big history of cattle grazing and heavy grazing in the woods. So there may be a tool you can use. Livestock, we're not a proponent of it yet, but there might be a way if you controlled browsing, you could control some of that too. We're looking at some different options. But currently, probably the best approach for a landowner would be to cut and remove or girdle those trees, or maybe use herbicides to get a little more light to the forest floor. Again, work with your forester to find out a prescription that makes sense for you. And it doesn't make sense necessarily to spend a bunch of time and money to get oak seedlings on the ground if you're in a young forest, because that's the forest canopy that's going to dominate for a long time. So it's a matter of where you are and the timing of it as to whether it makes sense to invest in some of those practices that can encourage oak. Is it possible to offer our property to pilot or test new practices on some of these mid-story options? It's possible. Jarel, do you want to talk about, and I believe this landowner might be up in Hocking County. So you want to talk a little bit about the possibility of private property and demonstrating practices?
I love hearing that idea and that offer of assistance. And so what I'll say is this, is most of the landscape in Southeast Ohio is controlled by private family woodland owners, and the future of that forest condition will be determined by them. And I think it's really powerful to have neighbors speak to neighbors. And one idea that we have as we work on this interagency forestry team is for us to work more efficiently together, so we as government agencies have more capacity. And so if you've got this great relationship with your service forester, we're definitely interested in exploring opportunities for demonstrations on private lands, and to have private woodland owners be advocates and a voice for what can be possible and share lessons learned. So am I answering the question?
I think so. And as far as, you know, the demonstration side and the research side, we have limited capacity to do real research, but applied research could be done on a lot of properties, and keeping good records of the practices that are happening out there is key. We're looking at a technique or a system so we can get better records on some of our herbaceous, or I'm sorry, some of our understory control of non-native invasives, and tracking that so we know what works. But the other big piece, I think, is the education side. We would love to have landowners where we can do, once we get past COVID, we can do more programming locally on a property with a landowner that's actually actively managing, so that we can encourage more landowners to do that. And we've got a program that's in the works. We're not ready to launch it right now because mainly of COVID has slowed us down, but we're hoping to get more on the ground educational programs locally. So it's in a county, we're bringing in local landowners to exchange ideas and then have the researchers and the service foresters and the soil and water and all the partners there at the table to interact. So I think that's awesome. Appreciate that offer. I think we're getting there. Let's see if there's anything else. I got a much appreciated. Yep, I think that covers most of it. Anything else? So we're running about an hour and a half into it. So I think that's a great way to, or time to probably end the discussion. Let's see. Yeah, there's one in there, but I think we're good. So appreciate Jarel and Lisa today. And again, these resources will be available. The videos will be available for folks, and get out there and enjoy it. It's a beautiful day. And again, thanks so much to our presenters for today. So everybody have a great day.